I am Bhaswati Hazarika from Department of Computer Science and Engineering, Assam Don Bosco University. I am going to present before you my paper on window-based state monitoring in cloud data centers. The contents are objective, introduction, related work, proposed plan, implementation, testing result and observations, conclusion and future work references. Now, the objective. The prime objective of the paper is to present a state monitoring framework for efficiently managing cloud applications. For this approach, we have proposed a system to develop a method to monitor the activities of the nodes in a cloud data center environment. The violation will be reported if the violation detected is continuous, that is, when the normal state is continuously violated for certain times. We propose the approach of window-based state monitoring in cloud data center in virtual machines of a cloud data center environment. The violation here is considered if the CPU utilization threshold is exceeded continuously for different user requests. Thus, we propose this system for lowering the violation reporting in cloud data center environment. Now the introduction of the proposed system. A data center, which is a facility for housing computer and its associated components, such as telecommunication and storage system. A cloud data center, it is the advancement in data center. A cloud application, the delivering service over the internet. Examples of data center. The National Climatic Data Center NCDC. It is a public data center that maintains the world's largest archive of weather information. Next is the Amazon's Elastic Computer Cloud. It is designed to make web-scale computing easier for developers. Now the data center management. Cloud services are provided through large-scale data centers. Data center management activities have got few fundamental tasks. One of them is monitoring that keeps track of the desired hardware and software metrics. Next is the data analysis that processes such metrics for resource provisioning, troubleshooting, or other management actions. In order to properly manage such data centers, both monitoring and data analysis is required. Next is SLA management. SLA is service level agreement. Monitoring is quite mandatory and instrumental in certifying service level agreement when auditing activities are performed to respect regulations. The administrator needs to monitor the requirements of the user and the condition or state of the virtual machines to handle SLA. Thus, we designed and implemented a cloud environment with multiple number of virtual machines. By implementing the window-based state monitoring algorithm, we propose to monitor the virtual machines. Then we'll report the number of SLA violations due to higher CPU utilization. Now is the related work. State monitoring in cloud data centers. In this paper, they proposed the most existing state monitoring works that study communication efficient detection of constraint violation. These approaches often assume reliable internode communication with the presence of messaging dynamics that are common in cloud monitoring environments. Next is the communication efficient distributed monitoring of threshold count. In this paper, the study was made on the problem of distributed constraint monitoring. They proposed several algorithms for communication efficient detection of constraint violation. They study a different problem by using an instantaneous monitoring model where a state alert is triggered whenever the predefined monitoring values exceeds a threshold. Next is the service level agreement in cloud computing. This paper proposes a mechanism for managing SLAs in a cloud computing environment using the Web Service Level Agreement framework. Next is the service level agreement in cloud computing. This paper basically proposes a mechanism for providing services to SLAs in a cloud computing environment using the Web Service Level Agreement framework developed for SLA monitoring and SLA enforcement in a service-oriented architecture. Even though it is possible to cater for different cloud interfaces through a middleware, there is no universal set of metrics that can be monitored across cloud providers. Next is the efficient reactive monitoring. In this paper, the existing state monitoring work often shared the following assumption. Nodes involved in a monitoring task is perfectly reliable in the sense that they are always online and responsive to monitoring requests. A monitoring message can always be reliably and instantly delivered from one node to another. Assumptions do not always hold in cloud data center. Cloud applications are often hosted by a massive number of distributed computing nodes. Failures, especially transient ones, are common for nodes of such large-scale distributed systems. This is the dynamic voltage scaling with links for power optimization of interconnection networks. In this paper, energy management techniques in cloud environment have always been investigated in the past few years. They describe servers can be turned on off using dynamic voltage frequency scaling approach to adjust servers power status. Power status तो ना status होगा
চববিলাক আঁঠুৱা আঁতৰি শুই দিছে যে সেইকাৰণে মহবিলাক এইফালে গুচি আহিছে আৰু এইফালে নাই
And the next one is the modeling and simulation of scalable cloud computing environments and the CloudSim toolkit, challenges and opportunities. The study on CloudSim, which helps to model and simulate cloud computing infrastructures and application services. CloudSim is discrete event-based simulator. Every event represents a change in overall system status. Now comes the proposed plan. Here we propose a method called window-based state monitoring in cloud data centers. If a normal state is violated continuously for a given time, the system informs about it. Our case considers that if more CPU cycle is utilized in a particular virtual machine than the allocated one, or the threshold value is violated continuously, then only the state is considered as violation. Hence, reporting minimum number of SLA violation and improving less power consumption. Next is the structure of the proposed model. The virtual machine will communicate with the cloudlets. The cloudlets will communicate with the virtual machine scheduler, then the host, and finally the request reaches the data center server. And the virtual machine scheduler will monitor the activities of the virtual machines. Now we have the proposed algorithm. CPU utilization is equal to requirement by capacity. Requirement is the busy time of CPU and capacity is the busy time plus idle time. Threshold value is Ti and window size here is W units. We will assign the static threshold value Ti to each virtual machine where I equals to 1 to n. Ti with respect to CPU utilization for each virtual machine is calculated by equation 1. For each virtual machine, if Vi is less than Ti, no violation is reported. Vi is the CPU utilization at VMI. If Vi is greater than Ti, we'll wait for the window size to violate. If Ti is less than Vi1 to Vin is greater than Ti and violates the window size W, then the SLA violation report will be sent. Each virtual machine has dynamic resource needs. The default implementation of the application class simulates a workload of a web server. In case of the application, we can be thought of it as request. Cloud setup is executed with the following features. 100 hosts containing 100 cloudlets each. Each cloudlet ID and virtual machine ID is executed with starting and finishing time. In the cloud environment created, number of virtual machines are created in data center number 0. The number of virtual machines have been allocated to the host. Now we will compare the utilization threshold of the host containing the virtual machines. For comparing utilization threshold, we have to first look at the MIPS of the different virtual machines. And the metric for MIPS requirement is calculated by total allocated MIPS in percentage is equal to total number of requests into 100 by total number of allocation. For SLA violation calculation, we have the formula SLA violation in percentage is equal to total number of allocation minus total number of request into 100 by total number of allocation. Now the testing result and observation. We tested our project in CloudSim Simulator, which is a simulator for modeling and simulation of cloud environment. We have created 100 host machine in a data center and 200 virtual machine. After calculating the SLA violation metric in the data center using the window-based approach method, we have got the following output. Observation of window-based state monitoring approach. Total simulation time is 1649.60 second. Energy consumption is 0.33 kilowatt hour. Number of requests processed 222. SLA violation percentage is 6.46%. Observations of the traditional monitoring approach. Total simulation time 1679.60 second. Energy consumption is 3.48 kilowatt hour. Number of requests processed is 218. SLA violation percentage is 31.70%. Result analysis. Assuming the window size is 4, if we have number of violation 3, then according to window based approach, the reporting will be number of reporting will be 0, and according to traditional approach, the number of reporting will be 3. And if the number of violation is 9, then according to window based system, the SLA violation reporting will be 2, and according to traditional approach, it will be 9. And if the number of violation is 15, then according to window based approach, the number of reporting will be 3, and according to traditional approach, it will be 15. And now the graph showing the violation reports for both the approaches. Now is the comparison of CPU consumption in both the approaches. If the number of violation is 3, then the CPU consumed in window based will be 0 and CPU cycle consumed in traditional approach will be 1.5. And if the number of violation is 15, CPU cycle consumed will be 1.5 in window based system and CPU cycle consumed is 7.5 in traditional approach. And if the number of violation is 20, then in window based system the CPU cycle consumed will be 2.5 and in a traditional approach the CPU cycle consumed will be 10. This is the graph showing the consumption in both the approaches. Now the conclusion and future work. Cloud computing provides a large array of benefits but many challenges in this domain. One of them is monitoring that has attracted the research community. Here with our approach we have found significantly less number of SLA violation reporting. We have discussed the actual need of monitoring. Our future focus will be on showing the results on HTTP request of web-based application for lowering the number of SLA violation and thereby reducing the energy consumption based on the CPU cycle required. Now are the references. There are total 24 references. There are total 24 references. Thank you. Thank you very much.